Hello children, let us continue the fascinating story of structure of atom. Point number 4, radioactivity. A scientist named Henry Becquerel observed that there are certain elements which emit radiations on their own. He named this phenomena as radioactivity and those elements as radioactive elements. He found that there are three kinds of rays, alpha, beta and gamma rays in that radiation. Properties of these three rays are listed in this table. Alpha rays are high energy particles. They consist of two units of positive charge. They are actually helium nuclei consisting of two protons and two neutrons. Their penetration power is minimum. However, their ionization power is maximum. That means they can be lethal. They can melt human tissues in no time. Beta rays are negatively charged particles having mass that of an electron. Gamma rays are massless and chargeless particles having penetration power maximum but ionization power minimum. Atomic models. Many scientists came up with their atomic models explaining that how these charged particles are arranged in an atom. First came Thomson's atomic model. Thomson said that atom is spherical shaped in which positive charge is uniformly distributed over the sphere and electrons are embedded in it in such a way as to provide more stable electrostatic arrangement. Means force of attraction between unlike charges counters the force of repulsion between like charges. This model was nicknamed as plum pudding, raisin pudding or watermelon. You can imagine positive charge as pudding or watermelon and negative charge as plums, raisins or watermelon seeds. Drawbacks of Thomson's model. There were two drawbacks in Thomson's model. First, mass of an atom is assumed to be uniformly distributed over the atom. And second, electrons are static. They do not move. They are embedded in positive charge. Later, scientists found out that these two statements are not true. Next came Rutherford's atomic model. It was based on his alpha scattering experiment. This was his experimental setup, in which a thin gold sheet was bombarded by alpha rays. He observed that most of the alpha rays went straight through undeflected. Very few alpha rays were deflected by a small angle, and very rare, 1 in 20,000, were bounced back, means deflected by 180 degrees. These were not the expected test results. The expected test result was most of the alpha rays will be deflected by a small angle. Let us understand how. As per Thomson's atomic model, positive charge in a gold atom is uniformly distributed. When positively charged alpha particle approach them due to strong repulsive force between like charges, alpha particles were supposed to slow down and after passing through gold atom were supposed to deflect by a small angle. As per his test findings, Rutherford concluded that point number 1, most of the space in the atom is empty as most of the alpha particles went straight through undeflected. And point number 2, positive charge is not evenly spread. It is concentrated in a very small volume so that force of repulsion between two like charges is such to deviate the alpha particles by a small angle. And point number 3, by calculations, he showed that size of the nucleus is negligibly small as compared to the size of the atom. Rutherford came up with his atomic model. Point number 1, the positive charge and most of the mass of the atom is densely concentrated in extremely small region. He called it nucleus. Point number 2, the nucleus is surrounded by electrons that move around the nucleus with a very high speed in circular paths called orbits. This resembles our solar system in which planets keep rotating around the sun as electrons keep rotating around the nucleus. Point number 3, electrons and nucleus are held together by electrostatic forces of attraction. This model had two drawbacks. First, this model could not explain the stability of an atom. According to Maxwell, electron continuously loses its energy at every turn in the form of electromagnetic radiations. So finally, it should lose all its energy and fall into the nucleus, making atom unstable. And point number 2, it says nothing about distribution of the electrons around the nucleus and energies of these electrons. In next video, we will talk about dual nature of electromagnetic radiation and Planck's quantum theory. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.